we're going to go ahead and move on into our next activity. Today we are going to use a digital simulation to learn more about how raindrops form, both at the observable scale and at the nanoscale. I will give you guys time to explore the sim in pairs, and you will then use the sim to observe how raindrops form. Some guidelines for using the apps: you guys are going to be paired up, and one person will be using the simulation at a time, so you guys can decide who goes first and who goes next. Anyone can make suggestions about how to use the app. You guys will talk about what you observe, and then halfway through, I will ask you guys to switch so that the other person gets a turn. This is the link. I don't know if you guys can see that. There's the link. Okay. At this point, I will circulate as the students explore the sim. I will continue to encourage them to discuss what they are observing. I will listen for student questions or alternate conceptions as they relate to the basic components of the sim. Halfway through the free exploration time, I'll provide a signal for them to switch. I will also remind you guys that, feel free to play around with the keys on there. So choose different landscapes. And there's 12 different landscapes that you guys can choose from. Turn on the wind, turn it to left, turn it to right, turn it off to see what happens to the water molecules. But also you want to make sure that you keep the water molecule toggle on, just so that you guys can see it on the nanoscale level. If you just want to see it on the observable level, that's okay too. And this time I'll continue allowing the students to play around with the sim. And then I'll give a cue for the next, for them to switch over so that the next student can have a turn. Then after that, we would go through it together. I would allow the students, we come into a group discussion, talking about what we notice on the simulation. And then I would hop on and ideally have it on the screen behind me. And we would talk about what is happening on the nanoscale level. So what are some things that you guys are observing? And it doesn't matter if we observe the same landscapes, but feel free to share which landscape you guys were on, and then did you have the wind, and what happened? What did you guys observe? Allowing students to respond, giving each student a turn to explain what they had observed. Okay, so those are great observations that you guys made. And yeah, so basically, to sum up the simulation, right? When we start the simulator, we can see that the water is evaporating. And then once it has reached a certain temperature or a certain height, we can see that rainfall starts to happen, right? In order for water vapor to condense and turn into water liquid, it has to reach a certain temperature. Now, if we were to turn the air on to right towards the mountain, we can see that we're finally getting some rainfall on the mountain itself. And you can see that it's pretty rapid rainfall. But the same thing is still happening. We're still getting the water vapor from the ocean. And because the wind is blowing right, that water vapor, that are the clouds that we can see from the clouds, are moving towards the mountain. And once it's reached a certain temperature, the water condenses, hence the rainfall. Okay, moving on. All right. The sim and a globe are both models. A model is something scientists and engineers make to answer questions about the real world. How is a globe an accurate model of the Earth? How is it inaccurate? So some may say that it is accurate because it's shaped like a ball, has oceans, and land in the right shapes. Inaccurate because it's smaller than real Earth, it's filled with air, and has words written on it. Your drawings of molecules in your notebooks and the pictures of molecules in Water Encyclopedia are models too. Molecules don't actually look like that, and they are not that large, but these models make it easier for us to make sense of water at the nanoscale. Depending on what scientists and engineers are using them for, models show some aspects of the real world accurately, but inaccurate in other ways. The sim is an accurate model in some ways. For example, it shows water flowing down the mountain or into the ground, where it is stored as groundwater. How is a sim an inaccurate model, though? And then I would allow students to pair up, discuss the question, and then we'd come back together. I'd call on some volunteers to share. And then I would point out some of the inaccuracies. I'll write them on the board. So some inaccuracies would be that liquid, water, and vapor are depicted with two different colors, blue and pink, like we saw on the simulation, respectively. The colors distinction in the model enables us to distinguish between liquid water and water vapor. In reality, this is not what the molecules really look like. The molecules in water vapor and liquid water are the same. The difference between liquid and vapor is the arrangement and behavior of the water molecules. Molecules in water vapor are spread apart. Molecules in liquid water are close together, like we had observed when we were looking at the water in the cup versus the water on the glass versus the water vapor outside of the glass. Some areas in the atmosphere in the sim do not show any water vapor molecules. In reality, water vapor is present in all parts of Earth's atmosphere, even indoors. We're going to move on to activity 3, which is investigating condensation in the sim. So you guys are going to go back to the sim. You guys are going to observe molecules at the nanoscale to better understand how raindrops form. You guys are going to turn to page 22 on your notebooks, and that is going to look like this. Give me one moment. Like this. It says investigating where water vapor comes from. I will circulate and offer assistance as needed. I will allow time for students to complete the investigation and discuss the answers in their notebook. I'm allowing students at this time to continue working in pairs. I would essentially be going around answering any questions. Okay, so once I've given everybody some time and I made sure that everybody has finished answering the questions, we're going to be answering the following all together. What are the water molecules like before they condense? Students may say that they are more spread out as water vapor. What happens at the nanoscale when water condenses and forms a raindrop? Water molecules in the air come together into clusters to form raindrops. When water vapor condenses into liquid water, the behavior and arrangement of the molecules change, but all of the molecules are still there. Remember that in the sim, the color of water vapor and liquid water molecules are different. In reality, the molecules that make up water vapor and liquid water are the same molecules. They are just spread further apart in water vapor. So let's go ahead. We're going to take down this key concept. I would essentially write it down on the whiteboard. The key concept is that water molecules are far apart in water vapor and close together in liquid water. Okay, moving on. When does liquid water in the atmosphere fall as rain? I would allow students to answer the question. When the water vapor condenses into liquid water, it does not fall as rain right away. As we can sort of see here in the simulation, sort of doing a slow-mo for you guys. We can see that the more and more water vapor, it doesn't always mean that it will fall right away. What do you notice when raindrops form? And some students may respond, raindrops form after a lot of water vapor condenses into liquid water. Okay, activity 4, reflecting on raindrops. We will now use a digital model to show our thinking about what happens when water molecules condense to form raindrops. Remember, I had already sort of cheated and given you guys a look at it at the very beginning. So I want you guys to try to do your best with the information that was given, with the image that I gave you guys, and see if you guys can remember how it looks at the nanoscale level. Scientists and engineers use models to help them answer questions and to help them see things that are difficult to observe. Scientists also use models to show their thinking. So I would essentially play this video, which is the condensation modeling tool. We'll use it to make a model to show our ideas about what happens at the nanoscale during condensation. The video will play. They'll see that the image should turn out like this. So I'll bring up this image once again, and I would further explain what is going on. Okay. I would allow students some time to fill out this part of the activity before I move on. I would encourage them to discuss with their partner so that they can get some feedback whether or not they're in the right direction. Okay, once everybody's done filling that out, they've done their drawings, we would come together and we would talk about the image once more. And once again, we can see that the molecules are far apart in water vapor and close together in liquid water, and the temperature is colder in the liquid phase and warmer in the water vapor phase. Okay, so now that we're done with that activity, we can write another key concept. The key concept would be raindrops can form when enough water vapor gets cold and condenses into liquid water. Right. Now, based on what we discovered over the last few lessons, how do the hydrosphere and atmosphere interact? Students may respond with, water vapor in the atmosphere condenses into liquid water. The atmosphere is where raindrops form, which fall to the surface of Earth and become part of the hydrosphere. Remember that the hydrosphere is all of the liquid water and ice on Earth, and the atmosphere is the air that surrounds Earth. Over the next upcoming lessons, we will continue thinking about what we have discovered and how raindrops form. End of lesson. Thank you so much for participating in today's lesson. I hope you guys learned a lot. Keep your notes. It'll be most definitely beneficial to the following lessons. Thank you.